this even easier. If I'm on a number line and I'm starting at 0, and I say I get halfway on counting where I want to go, I end up at 6. If this 6 is the halfway point, what number am I going to end on? 12. Very good. What did you do? Okay, because you started at 0, you went to 6. Did you go up the number line or down the number line? Up. You went up. So it's 6 more than 6 is. So 6 is the halfway point of 0 and 12. Okay. What if I started at 10 and my halfway point was 23? Where am I going to end? You're halfway there. 36. You're right. I went up 13, but how many more do I have to go past 23? I go past 23, 13. So I would end at 36. Okay? 23 is the halfway point of 10 and 36. Now, does it work? Do you think it's going to work going the other direction? Let's say I started at 8 and I went to -4. Did I go up the number line or down the number line? How many? 12. I went down 12. So what's 12 further away from -4? Very good, -16. So think about it. All we're doing here is we're working backwards off of averages. We're just counting. The average between an 8 and a -16 would be add 8 to the -16, you get -8. And what's half of -8? -4. You're doing all that math by just counting on your fingers. This works the exact same way as counting on a number line as it will when we have an endpoint to an endpoint, and somewhere in the middle is a midpoint. For example, if I have coordinates, 3 and -4 is my starting point. My midpoint has a coordinate of 6 and 2. What do I end up on? Well, going from 3 to 6, do you go up or do you go down? How many do you go up? What's 3 more than 6? 9. Going from -4 to 2, do you go up or do you go down? How many? 6. What's 6 more than 2? 8. So the other endpoint, if A starts at 3, -4, the midpoint's at 6, 2, that means that your other endpoint of the segment is at 9 and 8. All we're doing here, ladies and gentlemen, is counting. We don't need to do, well, the midpoint for the x's is at the whole formula, where this value is 6, this one is 3, plus whatever this one is over 2. What you just did is that you solved a 2-step algebra problem by counting. That's it. It's much easier to go up or down and count, because here you multiply by 2 and you subtract 3. Didn't we get the same thing? Which way is easier? Counting. There is absolutely no reason to do math for this problem. Let me show you again. We start at -6 and 4. We pass through the midpoint at -10 and 1. Where do we end up? I hold that for you. So think. -6 to -4, or -6 to -10, excuse me. Did we go up or did we go down? Up, down? Up, down, left, right, stand up, sit down, fight, fight, fight. Go away! So from -6 to -10, do we go up or down? How many? What's 4 less than negative 10? Positive or negative? Okay. From 4 to 1, up or down?
I didn't say up.
What's 3 less than 1? Going from 4 to 1, you go up or down? How many?
Wait, we subtract?
Sometimes you subtract, sometimes you add.
What is the
3.
I can't hear you with your face down like that. You're finding the missing endpoint. So what's 1 minus 3? Negative 2. Again, you're going to be given point A, you're going to be given a midpoint. Write this down and you'll remember it then. Trust me. If I started an ordered pair, my ordered pairs besides playing with our hair, looking at the picture on our computer. Thank you. That's just a reflection, I know. Thank you. We start at the ordered pair. If we just pick values, I'm just picking numbers. 0 and negative 7. That's my starting point. I go halfway and I wind up at 4 and 2. I look at the x values, 0 and 4. Did I go up? Did I go down? Up. I went up 4. What's 4 more than 4 then? 8. Negative 7 to 2. Those are the y values. From negative 7 to 2, I went up how many? What's 9 more up from 2? Done. You can do algebra all you want. Sometimes you don't need to. Every geometry book I've ever seen shows you walking through all these long-winded algebra problems. All you have to do is count. It works every single time. Okay? Even if you have fraction, it doesn't matter. All we're doing is just trying to see if you're going up or down. Okay? You don't believe it?
No, I don't know what you're talking about.
The midpoint of segment AB is M at 5, 8. The endpoint A is at 2, negative 3. Where's B? What do you think I'm going to suggest that you do? Exactly. Seriously, guys. The more you draw stuff out, the more you visualize what you're talking about, the easier a lot of this becomes. And that's the idea by visual representations. It's the idea of, you know, when I use those the compass and the straight edge to show you guys how you can create things, so that way it might help you retain the idea of what you just did. So if I draw this, I have endpoints. I have a midpoint. A, 2, negative 3. Midpoint, 5 and 8. From 2 to 5, do you go up or do you go down? How many? What's 3 more than 5? Negative 3 to 8. Do you go up or do you go down? How many? What's 11 more than 8? There you go. If you're going from negative 3 to 8, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. That's 11. What's 11 more than 8? All you're doing is counting. You don't need to do math. It's counting. I mean, you can take off your shoes and take off your socks and probably count all these problems between your fingers and toes. It might smell really bad, but it can work. You're just overthinking it. It's really that easy. Last one. Find the missing endpoint of AC if the midpoint is B. Remember, a lot of times they just change the language on you. They just change the endpoint. They change the midpoint letters. That's all. But the process here doesn't change. And that's what's kind of cool about this. No matter what we do, the process to solve this problem is always the same. And I notice so many students like the idea of having the same setup each time because it's easier to remember. Well, this is one of those cases. When we have a missing endpoint problem, you do the same thing every time. You draw a line, you plot them, and you count. So in this example, we're going from negative 12 to 4. Did you go up or did you go down? How many?
16.
What's 16 more than 4?
20.
20. From 8 to 0. Did you go up or did you go down?
Down.
How many?
8.
What's 8 less than 0?
Negative.
Done.
8.
What I want you to do tonight is the very next page over. It's on page 20. It's the same section. And I have 6 of them for you. I'll put them up on the board so you can take a picture. You can probably get them done before you get out of here. It's numbers 25 through 30. So it's the same section.
Is it all of them?
25 through 30, yes. This is page 20. It's still the same section, 1.3. I want you to do 25 through 30. Yes, please. Just put them on the exact same stuff you guys are working on, and we'll just go through them from there. I know that we've sold through a lot of those multi-view calculators. Please, please, please make sure you guys get one the next day or so, because starting tomorrow, things have to be in simplified radical form. Which means if you don't have that calculator, you have to know how to figure out what the square root of 12 is. You have to know how to figure out what the square root of 18 is. Things like that. Those calculators, you press a button. Everything else you got to do math with. I don't know about you, I'd rather press a button. My brain hurts. All right, questions on these? So this is pretty quick. Notice the language here. R is an endpoint, M is a midpoint. You're finding point S. So you have to just be honest with you. If you're using a pencil, draw one line and just keep erasing your letters, or keep erasing your numbers and just keep reusing it. You'll be done in 5 minutes. Okay? Yeah, today's pretty quick because there's not much here.